We're up and running. Hi, kids at home. You trying to taste that? What taste that is? Yeah. Yeah. Well, it's just a chemical. All right.
Yeah.
Two events. Oh, what was supposed to go in there? Hold on a second. Let me find out. Oh, it's something about independence. I would say two events are independent if the occurrence of either of them has no effect on the probability of the other. Two events. It has to be independent.
It's a long word and a short.
Yeah, so it's independent events.
Two events independent.
Yeah, it doesn't make sense.
Wait.
Alright, so independent events are when the anyway, it's called independence. When something happens and it has no effect on something else happening. Okay? So when I toss a coin 2 times, and we're going to assume it's a fair coin. When I toss it 2 times, so what could happen? Right? It could have heads then tails, tails then heads, 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 tails, tails. All right. So if I flipped a coin and it was tails, oh, here we go. If I flipped a coin and it was tails, all right. Does it have any? And I want to flip it again. Does it have? Because I had tails, am I more likely to get heads in this one? No. No. It's 50-50. So those are independent events. Flipping a coin twice. Good job. Come on, we just started. We're on chapter 11, page 23, and we only have a few minutes. And Haley, we're going to meet here tomorrow and Monday. Okay, so we're going to try to get some extra days in so we can review our last test and do all that kind of stuff before that. So it's bad news that we have to be here, but it's good news because we're going to be able to get this. If you're watching at home, there's going to be a lot of videos start showing up. Okay. So, what's the probability? What's the probability? What's the probability of tails and then head? So in other words, I'm going twice. I'm flipping the coin twice. 11-7? Yeah. Okay. All right. So let's do this, and I'll talk to you. All right. So which one is it? So we want a probability of tails, and then we want to do probability of heads. So the probability of tails is 1/2. The probability of heads is 1/2. The question is, what do we do with those? Add them?
Still be 1/2.
If I added a half and a half, what do I have?
A whole.
A whole.
But it's not.
That's not. No, what is it? Tails and heads, we already know what it is. It's 1 out of 4, right?
Yeah.
So it's multiplication. If you're debating whether I should multiply or divide, multiply or add, it's probably almost always multiply. All right, so here's the formula. Now, be careful about that word and. Okay? It's not the same and as sets. It's similar, but and means that 2 things are going to happen here. All right, so let's go back to our jar. We have 4 white marbles, 3 red, 3 blue. We select a marble at random and then put it back in the jar before another marble is selected.
I want a blue marble.
Find the probability of red, then red. Red, then red. I want to pick out a red one, and then I want to pick out another red one. So how many red ones are there? Is it 3 out of 10? Okay. Did I put the marble back in?
No.
Yes. And so now the second time I pull marble, it's still 3 out of 10, which is 9 out of 100. And I'll take fractions or decimals. Your homework, just be careful. Expressions you do the problem right, and then type it in the wrong format. Also, calculators switch back and forth pretty easily. Okay, Now, do you realize if we didn't replace the red one, we lost our independence? Because then the second one, two events are dependent. I think I lost the word "are" on the front page. Okay, if the occurrence of one of them does then have an effect on it. Okay. So the probability of A and B now is the probability of A times the probability of B, and there's this little symbol, a straight up line, that means given that A's already occurred. So this means given that. Given. The formulas look weird to me because you got a new symbol that we got to remember, given. However, I think it makes more sense just to do common sense. So same jar, 433. One marble is selected at random, but now this one does not get put back into the jar. So the probability of a red, then another red. The first time I draw a red, there's 3 out of 10 of them, right? Then there's 2 out of 9. Make sure you subtract from both the numerator and the denominator. So I got 6 out of 90, which is 1/15th, which is equal to, I should know this. Is it 0.063 repeating? I'm not sure. I think they take 1/15th. It's not 0.063? 0.066. Dang it. I was off of a third. 0.06 repeating. Okay. So here are the good ones. Ready? This is homework. This is final. This will be on my test. Okay? So, South Florida, the probability that it will be hit by a major hurricane is 5 out of 19. Okay? What is the probability that South Florida will be hit by a hurricane in 4 consecutive years?
Multiply that 4 times.
Mm-hmm. Because it's independent, right? 1 year is independent of the next year, we would assume.
Yeah.
Oh, we had a hurricane last year, we're not going to get one this year. That doesn't happen. So it's 5 out of 19 times 5 out of 19. Now, you guys are smart enough to know that I don't have to do that, right? I can just go 5 out of 19 to the 4th power. And this can be a pretty wicked fraction. Decimal and fraction. Because I don't know what 19 to the 4th power is, do you? 5 divided by 19. Ooh, I put 09. 19. So go that. And then I'm going to go to the 4th power. And I get 625 over 130,321. More than likely I want that as a decimal answer, which is, I have no idea what it is. Because somebody grabbed my calculator and didn't teach me how to do this. Is that under menu?
Mm-hmm.
Convert to decimal.
Mm-hmm.
Boy, that seems like a lot of buttons. 0.004796. Very, very small chance of that happening 4 years in a row.
Still a chance?
Alright, so now here come some good ones. Ready? What's the probability that South Florida will not be hit by a hurricane in the next 4 years? Are you doing this on your fingers?
I always do not.
For this question, you can do this on your fingers?
Well, you just do 14 out of 19 and then you multiply it 4 times.
Right. So we want to make sure it's not hit by a tornado, a hurricane, right? For 1 year, and then the next year, not hit by a hurricane, not hit by a hurricane.
Where are we getting 4? Because it was 5 out of 19 that it would hit, and so for it not to hit,
Got
it
it.
needs to be the opposite.
Okay.
I'm so
So the word not. So remember, not means 1 minus the probability that it. Yes, it did happen. Sorry. Not means 1 minus the probability. So we got 14 out of 19 to the 4th power, which is something. To the 4th power, and change it to a decimal,
What about I really don't have 15?
and I got 0.29478. So about a 30% chance that we're not going to have a hurricane hit South Florida in the next 4 years. So what's the chance that it might get hit by at least one? About 6%, right? Look at the next question. So here is the new thing, okay? And that is the word at least. Okay, so at least means 1 minus the probability of the opposite of what you're asking. Okay, 1 minus the probability that it will not happen. So at least is a really weird one. However, if you did this, right, it makes sense because, well, I don't care if it gets hit once, twice, 3 times, or 4 times. Okay? I don't care. That at least once is all those. The only thing I really care about is it doesn't hit. So it's 1 minus doesn't hit. And so that would be 1 minus 0.29478, which is 0.70522. I think these are one of the harder ones, the at least. The at least. The good news,
kind of comments.
it is. And the good news is they ask in the same way.
30% that it will not happen.
Right.
And then
So it has to be 70% that it happens at least once. So watch your homework, because the final question, my question, will be in the same format. Kids at home watching on videos, they're not watching the video, they're playing the video, which is a whole different thing. Okay. What time do we get out here today?
30.
we have one more page for the
We're good. Oh yes, perfect. This is perfect. All right. So there's that formula for dependent. Is called the probability that B given A is called conditional probability. All right, ready? What's the probability of rolling a 3, and there's the word given, so there's the line, that the outcome is less than 4. So I used to have a die up here. I don't know what to do with it.
Can you say again what the word
Given. Given. And basically they're going to give you one more piece of information. Okay? And when they give you that piece of information, the probabilities change. So what's the probability of just rolling a 3? Normally. 1 out of 1 out of 6, right? Okay, now, so here's that piece of information. I rolled the die, but I didn't let you see it. But I told you it's less than 4. I'm telling you right now, I'm looking at it, you're not seeing it. I'm telling you it's less than 4. Now what's the probability? It's a 3. Is it still 1 in 6? 1 out of 6? I'm telling you it's less than 4. I've rolled the die. How many numbers are less than 4? 3. So it's 1 out of 3 now. So this is equal to 1 out of 3. So I limited the denominator. So every time that they give you something, it's going to change the probability. It is the hardest part of probability, conditional probability. The good news is this is it. 11.8 is not hard. Okay. So here we go back to our
I hate
the deck of cards. Yep.
Ugh.
On the probability of getting a 9, given that you were given a black card. So what's the probability of 9 given that you were given a black card?
That'd be 2 out of 52.
All right. So 2 out of how many? How many is 52? How many black cards are there?
Oh, half of 52.
Yeah, 26.
Why only?
So
Are there,
what's the probability of a 9 normally?
are there only 2 9s?
There's only 2 black 9s.
And then there's 4.
So, and then normally probability of 9 is there's 4 out of 52, which is also 1 out of 13.
You should just give us a deck of cards.
So I don't mind doing that. I do not mind doing that.
You know how many questions I asked him about the deck of cards? It was ridiculous.
2.
So those.
Okay.
I did
All right.
ask him 2.
So look, the probability of 9 was 1/13. The probability of 9 given that I told you something, black card. So since the probabilities stay the same, drawing a 9 and drawing a black card are actually independent events. The probability didn't change. So that's not a great. This is a good one for conditional probability. This one's not a good one for conditional probability because you can't do the same thing. All right, ready? So here's how you'll see it as well in a chart table. Find the probability of surviving a car accident given. Okay, so when they give you something, the driver wore a seatbelt. So we are only looking at one car row. Because we don't want to look at all the other stuff. So the probability of survival given seatbelt is equal to how many survived? 412,368 out of 412,878. Once you see the word given, we're not using the full chart. 412,368 divided by 412,878. Oh my goodness. And of course it gave me a decimal. I mean a fraction. So it's 0.9988. Now, that's part A. Part B. Find the probability of wearing a seatbelt given that he or she survived. So now we're looking only at this row because they said given. We're only looking at drivers who survived. So the probability of seatbelts given that they survived. It's 412,368 out of 574,895. I'm getting better at this. 0.7173.
All done.
All right. You okay with the given part? It's a little weird. Work through your homeworks. Let me know if you have questions. That's 11:7. We'll do 11:8 tomorrow. We'll do 12 on Monday. Then we'll start reviewing on Wednesday, Friday. Thanksgiving will be fine. We'll come back. We'll review again, and we'll be in good shape.